As you probably already know, most of the world's water is in the oceans, frozen in the ice caps and glaciers, or in groundwater that's too deep or too salty. So only about 0.0024% of the water on Earth is actually available to us as liquid freshwater found in accessible groundwater, lakes, rivers, and streams. So this picture kind of shows that broken down, but I like this bottom part the best because if you take the total water and you say it's 26 gallons, of that 26 gallons, 0.8 gallons of it would be fresh water, about 3%, and then only about half a teaspoon of that is actually readily available fresh water. So even though we are the water planet, there's not actually a lot of drinkable, usable water available to us. Here, I want you to notice the difference between the location of available water compared to the world population. So for example, in Asia, a little over 60% of the world's people are in Asia, but there's only about 36% of the world's water in Asia. So there's a pretty big discrepancy in where the water is and where the people are. So we said that groundwater is one of our main sources of water. And groundwater is water that is underground, so it does not include lakes, rivers, and streams. Those would be our surface water. So groundwater comes from precipitation that infiltrates the ground and percolates downward through spaces in soil, gravel, and rock. And the zone of saturation is an area that's completely filled with water. And the water table, you might have heard that term before, is the top of that zone of saturation. And this level can fluctuate up or down depending on the amount of precipitation or just the general climate of the time. So during times of drought, that water table will drop. And during times of a lot of precipitation, the water table will rise. Aquifers are underground caverns containing water. There's a couple of different types. Unconfined aquifers have permeable layers surrounding them, whereas confined aquifers are literally, they're confined by impermeable rock layers above and below. So your unconfined aquifers are easily renewable and can be replenished naturally by precipitation or through lateral recharge from nearby streams. But the non-renewable aquifers are usually so deep underground, and because of the impermeable layers surrounding them, they get very little, if any, recharge and must be used or drawn from limitedly, sparingly. A couple of examples of non-renewable aquifers would be the Saudi aquifer under the Saudi Arabian desert and the Ogallala, which is here in the U.S. in our Great Plains region from North Dakota to Texas. And those, we have to be very careful not to overdraw from them because they take so incredibly long to replenish. So as I said, our surface water includes rivers, streams, lakes, reservoirs, ponds, wetlands, estuaries, water that is on the surface or above the surface of Earth. And when we talk about surface water, a lot of times we'll refer to the watershed. And the watershed or drainage basin is the land from which surface water drains into a river, lake, wetland, or other body of water. And what we see here is the Mississippi River watershed, which, as you can tell, covers a large amount of the United States. The smaller tributaries and rivers ultimately flow into the Mississippi River, which then ultimately flows into the Gulf of Mexico. And we look at watersheds and the health of a watershed to kind of keep track of how well water is being replenished and how polluted it might be. You see the dead zone here in the Gulf. It's the dead zone because of all of the stuff that flows from everywhere and ends up in the Gulf of Mexico and doesn't really allow for a lot of life in that part of the Gulf because of all the pollution and stuff. So we have to monitor our watershed. So I wanted to show you this little graph here, these two pie charts because I want you to notice that whether it's the United States or China, the vast majority of water, particularly in China, is used for agriculture. Even this graph here in the US, it's showing all of the US, but since most of our agriculture actually occurs out west, where the climate is a lot drier, this graph is a little misleading. We actually use a lot of water for agriculture, for irrigation. So that's just something to take note of. So on these two maps, I want you to notice that in the eastern US, we get plenty of precipitation, while the western and southwestern states have very little. And then if you compare the available water, the shortage of water, again, in the eastern US, we have an adequate supply of water, but then out west, a very acute shortage of water. Yet that's where most of our agriculture occurs, is out west. So that's what I was saying a second ago. Irrigation counts for 85% of water use in the arid and semi-arid areas of the western US. So we have to kind of be aware of that. So this map is showing global water stress, which just refers to how available water is to those areas. So things that can affect water scarcity, dry climate, drought, too many people using and wasting water, a lack of money to drill wells, build dams and storage reservoirs, and water distribution systems. So an interesting little stat, in 2005, 1 of every 6 people lacked regular access to enough clean water for drinking, cooking, washing, and sanitation, which continues to get worse as the human population increases. So obviously, groundwater being one of our main sources of water, we have to be able to withdraw it from underground. So, there are a lot of advantages of doing that. It gives us water for drinking and irrigation. It's available year-round. It's almost everywhere. It's renewable if we don't over-pump it. But we have to look at the disadvantages too. If we do over-pump it, it may take a long time for that aquifer to replenish. You get the subsidence where the land sinks. You get sinkholes from over-pumping. If pollution gets into those aquifers, it's very, very difficult, if not impossible, to get rid of or remove. And you get a lot of saltwater intrusion in coastal areas, and that makes the water salty, and it's too salty to drink. So there's advantages and disadvantages to using groundwater. So I mentioned earlier the Ogallala aquifer, and you can see that we are overdrafting the aquifer, and so we have to be very careful about that and try and come up with ways to mitigate that and limit our use of that water. So what can we do? Well, we can try to waste less of it by coming up with techniques to reduce evaporation and things with irrigation, ban new wells and aquifers to reduce the amount of people drawing water from the aquifer, raise prices to discourage use and waste, overuse, not use in general, but overuse and waste. Tax water, again, money speaks, right? So if we raise the price or we tax it, that's going to decrease its use or misuse. So these are ways that we can limit our groundwater depletion. Another issue is the need to transfer water. Some areas have plenty of water for what they need it for agriculture and stuff, but other places, either because of higher populations or a drier region, or they do have agriculture going on in areas where there's not as much water. So water needs to be transferred. So the advantage of that is it makes water poor areas more suitable for growing food and grazing stuff. It increases jobs, stronger economy, all these good things. But some disadvantages is that it encourages unsustainable use of water, because people start to think, well, it doesn't matter, we can always get more from somewhere else. So it leads to a lot of conflict in areas. One option that's been talked about is the idea of desalination, which is removing salt from brackish or ocean water. But the problem is it's really expensive and it does create waste. So there's two main methods. On the left here you see distillation, which involves heating salt water until it evaporates, which leaves the salts behind, and then you collect the condensation, which is fresh water. The other type on the right here is reverse osmosis, which uses high pressure to force water through a semi-permeable membrane that the salt cannot pass through, but the water can. Again, both methods are very expensive, so they're not really right now, the technology isn't there for it to be widely used. Some other alternatives they talked about in the video that we watched, cloud seeding is where you can add dry ice or chemicals such as potassium iodine to stimulate rainfall, but then that means it's falling over where you are and not falling somewhere else where they might need water, so that causes problems. We could tow icebergs, but as you bring them farther south, they're going to melt and you're going to lose some of the water into the ocean. You can collect spring runoff water in gigantic plastic bags and then tow those or carry those to other locations. But again, not very easy to do and quite expensive. So since irrigation is one of the main uses of water and ways that we lose water because of evaporation, there are different options for trying to save water and reduce evaporation. So kind of the old style was to just spray water willy-nilly on the field, but that would a lot of it would evaporate and it wouldn't get to the roots. So with drip irrigation, the one here in the middle, you have tubes that go around the roots of the trees or the plants and deliver the water more directly. And so it's going to the roots where the plants actually take it in. And so you can see the efficiency is 90 to 95%. That's probably the most efficient method. Center pivot can be somewhat efficient because it's not spraying quite so high above the ground. It's a little lower and more directly sprayed onto the plants. But again, the most efficient is drip irrigation. So going to hit the highlight here on reducing irrigation water waste. A couple of the best ways would be irrigating at night to reduce evaporation, monitor soil moisture to add water only when necessary. Don't grow water-thirsty crops in dry areas, duh. Grow water-efficient crops using drought-resistant and salt-tolerant crop varieties. Irrigate with treated urban wastewater. The plants aren't going to care if it's not drinkable for humans. So these are options for reducing irrigation water waste. So I'd like you to take a moment and pause on this slide and read through ways to reduce water waste. There's a lot of really good things here that you personally can do at home to help reduce your water use, particularly water-saving toilets and shower heads, turning the water off when you brush your teeth, that kind of stuff. So pause and read through this list. All right, we're going to spend more time talking about dams in class, so I'm not going to spend a whole lot of time here. But obviously some of the pros would be being able to collect and store water in the reservoirs. We can produce electricity by making hydroelectric dams. It can help control flooding, particularly downstream from the dam. It can provide water to cities, towns, and rural areas. It provides water for recreational activities such as swimming and boating and fishing. But cons, you get a lot of water loss due to evaporation because you've got this giant body of water. You have to flood land that was previously habitats for organisms, and it can displace people. There's danger of dam collapses, which can cause tremendous flooding downstream if that happens. Downstream is depleted from the nutrient-rich materials that are no longer flowing downstream. It can disrupt migration and spawning of fish. They're really expensive to build. So there's a lot of pros and a lot of cons. So flooding has become an issue more and more. A flood happens when water in a stream overflows its normal channel and spills into the adjacent area, which is known as a floodplain. Floodplains usually include highly productive wetlands, provide natural flood and erosion control, maintain high water quality, and help recharge groundwater. But as people build on floodplains, they have rerouted streams with dams, levees, and walls. So there's several benefits to flooding. It can provide productive farmland because of the nutrient-rich silt left behind after a flood. As I said earlier, it can recharge the groundwater and refill wetlands. So flooding, natural flooding, has a lot of benefits, but each year floods are also killing thousands of people and causing billions of dollars in property damage because we're building in places where floods are prone to happen, which just increases flooding.